Twitter if you really want to get one of the goodies. It's very nice, and we're also going to a bar after this. So if you want to join and have a little bit more networking, be ready for that. And that's it. I leave you with Ben.
So the good news is I don't have to pitch you on the hiring stuff that much anymore, but we are hiring. It's awesome. You guys should come and join. But we're going to talk about building for the future at Snap, what we've been up to for the last, I guess, year and a half. So quick agenda of what we're going to talk about. So first is the problem that we were facing at the time and our solution for it. The platform that we ended up building for that problem. By the way, spoiler alert, this ends up being a rewrite of our app. So third part, we'll talk about why rewrite and whether or not that's a good thing to do. And finally, we'll talk a bit about how we actually went to launch it. So we didn't coordinate this, but I think this is actually quite a good talk to pair after Andy's. There's a lot of kind of similar things that we were dealing with, and kind of similar lifetime of our product. So I'm going to try and make a rocket ship metaphor. It might get kind of weird and ugly, but like we'll try it. So like, let's say like you built a rocket ship and like it looks like it might take off, like maybe. So like you launch it, and like you're really not sure, but you really want it to launch. Actually, this one, I think Andy's was unmanned, but you actually like put people in this one. And you just like send it out, and then you're like, you're patching it up while you're going. You're like sticking on duct tape and glue and like whatever you have available, and somehow you actually get through the atmosphere, which is like really crazy. And you're like, what am I doing up here? Like, I think we're not really prepared for this. And so you keep patching it and putting stuff on, and then you get to that docking stage. And you're like, this isn't gonna happen. Like we can't dock this thing. So what do you do at that point? So that's kind of where we were at when we were making these decisions. So Snapchat, I think we're about 8. The product itself is about 8 years old, and in that time we've grown quite a bit to support a lot of different features. So it started as kind of a simple camera that friends used for, let's just say, various picture types. It grew quite a bit from there to support, the next obvious thing was to support full-blown chat, so people could actually send text as well as their pictures. The chat product grew quite a bit, and then we added, a video app very similar to YouTube. You can watch videos and browse videos. We even added a map. If you're a Snapchat user, you might have seen this. So, it's quite a complex feature. And it just kept going and going, and we keep, we don't really want to stop. We like being able to expand the features that we have in our product. We have augmented reality, video calls. Someday, I don't know, we might get into self-driving cars. Like, the sky's the future, right? So, things got pretty crazy. So, when you have such different, features, like a chat app and a camera, photo gallery, usually you organize this with an operating system, right? Like these are basically apps. But we started this thing in 2012, and frankly, hadn't done any real major refactors along the way. We were so focused on getting that rocket ship out of the atmosphere, just building feature after feature, and it's really hard to do that and balance the platform work you need to make that like a sustainable code base. So we started with what I think were some of the best practices in Android in 2012. Especially for an app that's relatively small. So things like an event bus that's global and shared across the app. Our main navigation was just a view pager, right? You have a camera, swipe left, swipe right to get to your chat screen and your story screen. And we had a database. Since we're just ephemeral messaging, we don't have that much data, right? So we have a SQLite database and just load the whole thing into memory, and it makes all the rest of your coding much easier. But feature after feature gets added. And eventually that database that was just ephemeral messaging turned out to be 88 tables in size. And the practices you put in place, you're still loading that into memory and kind of relying on it to do all of your work. So at some point, the patterns that worked in the early days of your company kind of stopped working. So specifically that database, for me, was one of the big red flags that said we kind of have to really rethink what we're doing here. Like we would literally, read the 88 tables into memory, and only then could we have enough information to make a network request to get the differences of messages that you need to display to the user. And on a Pixel 3, not a big deal. On like a J2 Core or below, it gets a little dicey. So the patterns that worked back, in the beginning of our app, kind of stopped working. So this is, if you guys are familiar with systrace, this kind of highlights the problem. Actually, it doesn't do a great job because we need like a giant portrait screen to show the 150 threads that we're running and all the work that's happening at startup. But the point is, just everything is just trying to compete for the resources and make everything fast and faster for themselves. So anytime you launch like a big new feature, we get into kind of this cycle. You build a feature, and I'm telling you this from firsthand experience. My first project there was our search feature. So we built it, code looked fine. You go to run it, and it's just not performing as well as you need to launch it. And so, the code, you tune it as far as you can. And at some point you say, you know what, like, let's make this stuff happen before the user tries to get to the feature. That'll make it run fast, right? That'll make our feature run really, really well. So we, take the views, for example, and we preload them on the background thread. It's invisible to the user, it's not gonna impact them at all, right? The problem is, of course, that impacts the app performance at large. And when you have, let's say, 5 or 10 features or 15 features that all have this mentality, it slows down the app so much that, of course, your feature starts slowing down again, right? So you get into this cycle, right, where you have, not just one feature in the cycle, but you have a dozen or more. So it grew to be a real problem. So we stepped back and we thought, okay, like, we need to get out of this mess. We can't just keep, stepping on the toes of every feature in this app. So what if we take a step back and say, these things that kind of look like different apps, what if we actually kind of develop them as if they were different apps? Right, we have a camera. What if the camera were like a self-contained camera? What if chat were a self-contained chat? Could we get away with that? Can that work for our product? So from there, we kind of defined this very simple contract for what we thought might work as a rewrite. And at this time, we weren't ready to think of it as a rewrite yet. It was kind of like a concept, like, well, if we did this, would it work? Can we bring this to the team and make it grow? So the rules are this. Number one, a module is not allowed to preload any work at startup, right? You have to break that pattern, just say, can't do it. Now there are some rare exceptions, which I might get into, or maybe we can talk later. But by and large, just can't allow it. Number two is to kind of enforce that good performance of each feature. Build a sample app that pairs with that feature so that you can run it by itself and work on and adjust the performance in its own little sandbox, right? If you do those two things together, if your sample application runs well, and if you put it in a box with other apps that are not interfering with your work, then you should run well as well, right? So that's what we tried to do. Another important part of that is to make this work. We had this thought that, well, the UI is a hard problem in itself, and in our old code base, we kind of had a lot of business logic mixed in with our UI. So we wanted to be really strict about separating the data layer from our UI layer so that we could really focus on tuning each one separately. So we took that principle and we kind of thought, okay, what's the module structure that we need to make this possible? So obviously we have a lot of modules that they're clearly going to need to communicate with each other. They're not actually separate apps. Like the camera needs to put photos in the photo gallery. So we kind of sketched out like what is our module pattern going to look like? So we set on this kind of basic pattern, have an API layer, a core implementation, and then of course the sample app that we talked about. So when you step back, this is what our kind of central architecture ends up looking like. We have an application layer that's allowed to reference any module across the code base. It's basically just composed of the features that you build. So we have a layer of features which typically don't depend on each other too much directly. Like we really want to avoid having dependency cycles. And the best way to do that is just to not depend on each other as much as possible. And then at the very bottom, of course, my favorite layer, because this is my team, we have the platform layer, which is all the framework code that is used to support the features that are used to support the app. So the hierarchy here is platforms are not allowed to reference feature components, and feature components are not allowed to reference application, right? So keeping that structure lets you scale up pretty big. I think there's some error, okay. I don't know how current this slide is, but at some point we had 16 sample apps for various features. I think we probably have 18 or 20 now. We had 2 top-level applications, which we still have, but one of them is changed. So the structure ended up working pretty well. To make the sample apps really easy, obviously, like most of our features require the user to log in to get access to the data that they need to build the feature. Some of them can get away with step data, but other you really want to be able to work with live data to tune your experience. So for that, we made a very simple, we call it a splash activity, which basically you just drop into your sample, and it handles the authentication for you, and it lets you use reference the user across the rest of your feature, so you don't have to work on that, deal with that. So we took these, we started prototyping. We wanted to see, like, is this gonna hold up? Is this gonna work? So again, our goal is, like, Snap is a camera company as our official party line. So we really want the camera to load as quickly as possible. So given that we load the camera as quickly as possible, our main question in this early stage of kind of concept was how fast can we load the friends feed given that it's not allowed to load at all? And that was like we had worked on this before introducing it to kind of the larger team because we didn't know this answer. Like, how fast can you build your screen given that, like, you just swipe to it and that's the only time you're allowed to reference it? Actually, I had this kind of revelation. This might be embarrassing, but in Android Studio, if you set a breakpoint, like, you'll get a check mark where, you know, when your breakpoint is active. But if you have like a fragment that's actually not code loaded yet, the breakpoint won't check. So like the entire time we were building our legacy app, I just saw checkpoints all the time because all of our code was just loaded right at startup. And so we start building this as a prototype. I'm like, why is there no check mark here? Like, you'd swipe in and it would show up. It was like, oh, cool. So then there become kind of two challenges here, right? One is you want the swipe to be quick. You want the content to show up very quickly. And number two is you want it to do it with as little jank as possible, as few frame drops on the main thread. This animation, of course, is a GIF, so it has some artifacting. But you see that kind of hiccup there, that's actually like part of this product at the time, which I'm kind of show off with, I guess, minor pride, because it's a really hard problem to build your UI while you're kind of in transition. We'll talk about that just a little bit. So when we started this work, we started prototyping the principles that we talked about, but we didn't really want to just build it as like a throwaway prototype, right? So for us, we thought about, you know, you've heard of MVP as minimal viable product. But for us, another part of this was minimum viable platform, right? We wanted to know, like, what are the set of frameworks that we need to support our larger team? Like, what is that going to take such that we can make this whole thing fly? So at this point, you know, as I mentioned, this does turn into a rewrite, which is very painful. But one of the biggest benefits of a rewrite is you get to really rethink, you know, everything that you're going to use to build the app. So we jumped from 2012 and the best practices in Android then up to, what was it, 2017, I think. And the landscape changed a lot, like, for Android generally. So it was a really cool opportunity for us to, like, see what was out there, see what was working for people, and make decisions based on that. So what we ended up with, RxJava. Any RxJava fans? Great. Dagger? Yeah. SQLite? Anyone? Nice. All right. If you don't know, SQLite is kind of competitor Room. Room you might be more familiar with. How about Kotlin? It's a good one. And then Retrofit for our networking stack. And so, you know, that was a great start. Like, that really pushed us forward, like, a lot, just from those. But Snapchat also has a lot of unique features and twists inside the app itself. So we knew that we were going to have to build some frameworks that were custom and that were kind of specialized to what we do at Snapchat. So I think one of the biggest ones ended up being, like, our navigation is probably one of the more unique things of us compared to many other apps. Like, we consider swiping to be a navigation action. I think we started this library before Android had put out their navigation framework, but someone can correct me if I'm wrong, but I think they wouldn't consider, like, a view pager experience to really be part of, like, a navigation experience, for example. And that, for us, is kind of the core of what we needed to build. So that, and there were just a lot of other just subtle nuances that we just, like, you just won't really find them in any other navigation framework. We also ended up building our own framework for managing recycler views. Recycler view is great. It's kind of critical for any, you know, scrolling UI, but it's really fairly, in some sense, low level. Like, you can have a lot of different patterns to support your recycler view, and we did. Like, every main feature had its own way of managing that recycler view, and we really wanted to kind of have a more standard experience. You know, somewhat to share UI across the different screens, but more importantly, just to help people, like, jump across screens and just feel like they can contribute to that code base right away. We also, some of our other big libraries, built out a pretty heavy, you know, we're very, very media focused. So focused a lot on our content manager and how we get media from the network onto the screen, especially how we deal with ephemerality, deletion, all that kind of stuff. And of course, creating a snap ends up being very complex as well. So we replaced what we used to call the snap womb and the media brio, which were the staples of our media framework on our original app, with a more sophisticated media package manager. And again, it was just a really nice chance for us to reset and get, like we knew the problems that we were gonna face. It's a good chance for us to spend some time to get them right. So I wanted to walk through a couple of the examples of what some of those frameworks look like. So here's a bit of a code sample from Deck. This is, again, our navigation framework. And so what we have here is we kind of think of